Ladies and gentlemen, please welcome the Chairman, President, and CEO of Convex Computer Corporation, Bob Paluck.
Good morning. Are you all ready for a really big show? All right, so are we. Well, in 1984, Convex changed the world of supercomputing with the introduction of the world's first affordable supercomputer. In 1988, Convex expanded the market for supercomputing by offering true supercomputing power to mid-range users that simply could not afford multi-million-dollar equipment. Well, today, in 1991, Convex is once again defining the role of supercomputing with the introduction of 20 compatible new products that offer the broadest range of air-cooled supercomputers in the world. You heard right, 20. To everyone who ever thought you couldn't keep a secret in this industry, I say think again. But today is more than just an introduction of a product. Today is the continuation of a report on a business strategy that began in 1984. A business strategy that has resulted in growth, big growth. This is what the scientific industry looked like in 1984 BC. That's before Convex. On this price performance chart, Cray owned the upper right and DEC owned the lower left. We saw the need for a product positioned right in the middle, at a price performance point that Cray wouldn't enter and DEC couldn't enter. And with the introduction of the C1, the word mini supercomputers entered the language. But we brought more than just a new word to the industry. We brought air cooling, low power consumption. We brought the concepts of open supercomputing and interactive supercomputing. We brought value to an industry long dominated by this is what it costs, so take it or leave it kind of philosophy. In other words, we brought value, and we brought leadership. Our software consisted of a high-performance vectorizing, optimizing Fortran compiler and a Unix operating system. These brought a rich, productive software environment to supercomputing. Our application strategy was a cornerstone of our business strategy. We knew what we did best, and we worked with third-party application designers to do what they did best. They recognized the importance of what we were doing, and their commitments to bring software came from all over the world. Our markets were universities, petroleum, government aerospace, and computer-aided engineering. These are users that needed more power and more value. And the uses for the C1 were rather simple, at least by 1984 standards, simply intensive compute applications. So now let's fast forward to 1988. While the supercomputer industry was still reeling in shock from Convex, we sent them a message that we were very serious about our business strategy. We introduced the C2 series. These were 7 mini supercomputers extended on a price performance chart from the C1 up through and overlapping the low end of Cray. All of these systems were compatible and upgradable. The C2 brought such technological achievements as automatic self-allocating processors for transparent hardware-based parallelism, non-blocking memory crossbar, and of course high-performance CPUs. We added a C compiler and an Ada compiler to our language base. These were the industry's first vectorizing and parallelizing compilers. We also added a production-capable parallel Unix to our operating system offering to satisfy the demanding needs of users in industry. This was all industry-first technology and all developed right here at Convex. Our strategy to provide a rich software environment succeeded with over 200 third-party applications ready for the C2. Parallel processing and the range of C2 products allowed entry into a fifth market, serving the pharmaceutical and chemical companies. And the C2's speed and memory were added new software functionality that opened a second use, visualization. The result of this business strategy was growth, big growth. In 1984, our sales were 0, and of course our installations were 0. We had nowhere to go but up, and up we went. The C1 took us to 70 million in sales and 260 installations by 1988, and up we went. The C2 took us to $210 million in sales and more than 850 installations located in 36 countries. But that was then, and this is now. We have grown to the point where Convex leads the industry with our extensive product offerings, innovative architecture, advanced system software, availability of third-party application programs, international distribution, and the largest install base of supercomputers in the world. Well, if the C1 is where we've been, and the C2 is where we are, then the C3 is where we're going. I'm pleased to announce the future of supercomputing, the Convex C3 series. The technological leader of the C3 series is the 3800 family, the world's first all-gallium arsenide supercomputer. Designed for corporate-wide use, the 8 products in the 3800 family offer from 1 to 8 CPUs, up to 4 gigabytes of memory, and a peak performance of 2 gigaflops. The most versatile member of the C3 series is the 3400 family. Designed for the departmental user, the 8 products in the 3400 family feature our most highly integrated processor ever designed, with from 1 to 8 RISC CPUs, 150,000 gate BiCMOS gate arrays, 2 gigabytes of maximum memory, and a maximum performance of 800 gigaflops. And the most cost-effective C3 is the 3200 family. Designed for the server environment, the 4 products in the 3200 family offer from 1 to 4 CPUs, ECL and CMOS technology, 2 gigabytes of maximum memory, and a maximum performance of 200 megaflops. With the C3 series, Convex offers the broadest range of air-cooled supercomputers in the industry, with the largest application library available and the most advanced software technology. With the C3, we add the industry's first application compiler and expand our Unix operating system to also include mainframe features. We now have over 1,100 applications that will run on the entire C3 series day one. What you're going to be seeing in the presentations over the next 2 days are many of the new applications that are coming out. I can hardly lift it, but this thing that is actually bigger than a Texas telephone book is our new application library manual. It's got over 1,100 applications in it. We add the environmental, real-time, and data file service markets to the markets we address. This brings us to a total of 8 markets that we now serve. And we add data acquisition and control and data management to the way our systems can be used across all markets. Now the C3 series can be used in 4 different ways. What does all this mean? It's rather simple. More markets, more application, and more uses. And that adds up to more growth. Well, our plan for the next hour or so is this. We'll begin with Jim Balthazar and a look at the markets and opportunities for the C3. Then Steve Wallach, Frank Marshall, and Jim will go into a little more detail on each of the 3 product families in the C3 series. Along the way, we'll hear from Convex customers who will explain in their own words just why our business strategy is working. And finally, Steve will give us a peek at how well the C3 will take Convex into the future of supercomputing. There's no question that to be successful in coming years, we must hold on to our 73% share in the mini supercomputer market while we expand into the higher end of price-performance scale in the supercomputer market. Here's Jim Balthazar to discuss the challenges we face and the opportunities that are available.
Thanks, Bob. You know, it's been really interesting leading up to this event. There's been a lot of press and a lot of activity in the marketplace. And just a couple of weeks ago, an analyst who's pretty well known in the business called me up to chat and said, by the way, I don't think I'm going to come to the C3 announcement. And naturally, I was pretty curious. I said, to myself, gosh, everybody's been so interested in this event, you'd think they'd be quite interested in the C3. So I asked him why he wasn't going to come. And he said, hey, it's simple. I already know what you're going to announce. Well, what I thought was, boy, we really can keep a pretty good secret. But what I actually said to him was, there's going to be some surprises. Well, what he probably thought when I said that was, surprises in this industry? No way, don't make me laugh. But what he told me was, well, maybe I will come. Well, I hope that analyst is going to be in the audience, because if he isn't, he's going to be scooped by everybody else that's in that audience. I'd like to begin this overview of the market and the opportunity by stating that most of what Bob said was true. Now, I know that's probably a risky statement for a mere vice president to make, but hear me out, Bob. He said that our business strategy began in 1984. Well, I'd really offer that that strategy began in 1982, and that's when Bob and Steve first founded Convex Computer Corporation. Their mission at that time was to provide affordable supercomputing to a mass market. Remember that back in the dark ages of supercomputing, that was back in 1982, supercomputers were found only in a very few government labs or the very largest of corporations. And thanks to Bob and Steve's vision, Convex has brought supercomputing to a level where every scientist and every engineer can afford it, at a price they used to pay for mini computers. By providing air-cooled technology and supercomputer class performance, we filled a need in the compute-intensive marketplace that we're continuing to take advantage of. With the C3 series, we extend our opportunity much higher in the price-performance range while we offer even our low-end customers substantial value and a tremendous growth path. If you haven't figured it out already, let me state right up front that the C3 series is a whole new concept in supercomputing, not just the next generation. By that I mean it's the broadest range of completely compatible air-cooled supercomputers based on open standards and augmented by the most advanced software technology in the industry. The C3 series is 3 families of products, each with its own unique characteristics. The 3800 family is what everyone is expecting here. It's what the press has been focusing on. It's the extension of the C2 family, and it's the one with real sex appeal, and it's the one that's going to challenge and beat Cray head on. In 1990, International Data Corporation estimated that this high-end market was $1 billion and would grow by 78% over the next 5 years. The C3800 gives us the opportunity to not only enter that market, but to quickly become a leader in it. It allows our 800 existing customers an exciting growth path into true supercomputing performance. In fact, we've already sold more than 10 C3800s to both new and existing customers. You'll hear from some of them throughout this program. The 3400 family is the one that no one in the industry expected. It takes over the price point of the C2 series, but at twice the performance. In case you missed that, I'm going to say it again. The same price point as the C2, but at twice the performance. Right now, we have a 73% share of the departmental supercomputer market. And the C3400 gives us the opportunity to further increase that share. The C3200 family may not have been expected in the public either, but this product enables us to reach a price-performance point that we have never been able to offer before. By combining proven supercomputer technology with engineering advances developed for the C34 and C3800 products, we can offer the C3200 family at half the price of the C2 series. And that's a low entry price of $350,000. The C3200 will make us even more competitive in the low-end market and will provide an ideal product for the server environment today. This market is now recognized as the fastest growing segment in the computer industry. I hope you're beginning to understand now why I called the C3 series a whole new concept in supercomputing. The entire series of Convex supercomputers is upward and downward binary compatible and provides the broadest range of air-cooled supercomputers in the industry today. The opportunity for growth is simply fantastic. Not only can we increase our share of the middle of the supercomputer price performance range, but we now have access to both the high end and the low end, price points with the most advanced technology available today. With our installed base of over 850 systems worldwide, we have a tremendous foundation to grow on. But you don't have to take my word for it. Let's hear from some of Convex customers who aren't just satisfied, they're buying more.
At the Mobil Oil Research Center in Dallas, scientists are using a Convex supercomputer to help locate new deposits of oil and natural gas. For Ross Huntley, the Convex has proven to be even more productive than expected.
Initially, Mobil started using the Convex computer in a seismic processing and seismic imaging role. But since that research began, we have moved it into a production role in seismic processing. On top of that, what has happened is that we've taken the system and tried to use it in hierarchical file management or hierarchical data storage. And the Convex is a key player in this research project.
As with all oil companies, Mobil is faced with the task of continually finding new resources.
The Mobile Research Lab is involved in exploration and production research. What this means is that we work all the way from seismic exploration and Landsat imaging all the way down to production research, where we figure out how to produce in the best manner from a particular formation and get that oil out of the ground.
Mobil uses their Convex supercomputer to help determine the most cost-effective methods of production.
When Mobil purchased the original C1, it was more affordable and user-friendly than the competition. What we've found since then is it fit very well into our networking situation, and a lot of the visualization features were much better than what we had at the time.
For Mobil researchers, visualization of data is vital, and with the power of the Convex, that data is right where they need it, on screen.
What we're trying to do here is bring researchers into a position where they can relate directly to their data online, rather than just produce plots and have people analyze plots. Text is meaningless to the average researcher. What he wants is a picture. He wants to see his data on the screen, a graphics analysis. A lot of our data sets go into many, many gigabytes, and to actually look at it and to see the picture is very meaningful.
Providing supercomputer solutions and customer support are top priorities for Convex.
The current relationship with Convex is excellent. They've always been strong in the service and support area. But as well as this, what we've felt is that they've helped us with third-party software and got involved in our problems. It doesn't feel like a vendor-client relationship. It feels like we're working with people who are almost on our own team.
People expect value from Convex, and we have a history of giving them more for their money. The C1 and the C2 series built this reputation with world-class manufacturing and top-quality products. While the C3800 family is certainly a value in terms of price performance, it's really a lot more than that. This member of the C3 series represents a technological innovation in its truest sense. And its unique packaging not only allows us to offer highly reliable air-cooled technology, but also true supercomputer performance. Here's the supercomputer that represents the first commercial use of gallium arsenide technology. Here's the maximum performance system in the C3 series. Here's the 3800.
To outdistance the competition, Convex introduces the C3800. With gas circuitry and up to 8 processors, the C3800 allows scientists and engineers to achieve superior performance with a low-maintenance air-cooled system. Reduce the time required to solve complex problems. Increase productivity and save millions of dollars in development costs. The C3800, the difference between winning and being left behind. Ladies and gentlemen, please welcome the Senior Vice President of Technology, Steve Wallach.
Thank you. In a recent Business Week article about Convex, Cray CEO John Rowagan is quoted as saying, "We must do more to make our products cheaper." I was both amazed and amused by this apparent Cray mission statement. I thought maybe we were going about this the wrong way. Maybe the strategy we've been using the past 9 years is 180 degrees off. Here we are trying to make our products better. The same Business Week article also asked a question about Convex that I would like to answer at this time. The question was, can its new supercomputer spar in the Cray class? The question is, you better believe it. The 3800 is Convex's first full-fledged supercomputer with credentials to back it up. The reason I feel this optimistic can be summed up in 3 Gs: gallium arsenide, gigaflops, and gigabytes. Let's begin with the revolutionary design made possible by gallium arsenide. The C3800 is the first supercomputer to fully utilize gallium arsenide in the processor design. This technology is faster than ECL at 1/3 to 1/5 the power requirement, but offers high reliability in a low-maintenance air-cooled environment. And it does this all in a compact package. In my opinion, gallium arsenide is the future of high-performance semiconductor technology. For this reason, the C3800 is on the bleeding edge of innovation. I say bleeding edge because our competitions will really bleed over our choice of gallium arsenide. In addition, the 3800 employs a revolutionary implementation of an advanced technology called Integrated Distributed Power System, or IDPS. With IDPS, each processor board contains its own power regulation system. This means that power and environment can be more tightly regulated and monitored than can be with central power distribution. It means a more robust, maintainable system. CPUs can be individually powered on or off, while the remainder of the system continues to function. This substantially increases the availability of the C3800. The second G is gigaflops. In the C3800 family, there are up to 8 64-bit CPUs. Each CPU is an integrated scalar, vector, and parallel processor that is totally compatible, upward and downward, with existing C2 processors. High-performance scalar processing is crucial for baseline speed for all applications. The scalar performance of an 8-processor C3800 is approximately 1,000 floating point MIPS, or 1 billion floating point operations per second. Consequently, a broad range of applications run efficiently on these systems. Vector and parallel optimization dramatically accelerates single job execution by performing multiple operations on multiple data elements simultaneously. The Convex compilers automatically initiate vector and parallel processing based on an analysis of user programs. This level of transparency benefits the user in 2 ways: increase in job performance and ease of use. 32-bit vector and parallel operations execute at 2 gigaflops, and 64-bit operations execute at 1 gigaflop. Now, Convex offers true supercomputer performance while still providing ease of use, low cost of ownership, low life cycle maintenance, air cooling, and small physical size. And to further increase performance, parallel processing splits the work over multiple processors, greatly reducing the time to solution for individual jobs. The Convex compilers, Fortran, C, and Ada, automatically detect parallelism and make use of the available processors in the C3800. In the C3800 family, processors combine multiprocessing with parallel optimization in a unique technology developed and patented by Convex called Automatic Self-Allocating Processors, or ASAP. ASAP technology allows processors to dynamically allocate themselves to keep all processors busy as long as there's work to be done. This results in an increase in multiple job throughput, essential when many users share a supercomputer. The third G is gigabytes. CPU speed alone isn't enough. Memory size and design must match processor performance. To easily handle the largest and most memory-intensive applications, the C3800 has physical memory capacity of up to 4 gigabytes. To efficiently access this main memory, a 9-way non-blocking crossbar switch is provided. To achieve performance balance in I/O and CPU, the memory system can sustain peak bandwidth to all CPUs and I/O. And the real memory is complemented by virtual addressing capabilities. Each executing process can use up to 4 gigabytes of a virtual demand page address space. 2 gigabytes are shared by the system among all processors, and 2 gigabytes are available per process to each user. This increases multi-user throughput dramatically because all these portions of a process needed for execution reside in physical memory. And efficiently use main memory, and efficient use of main memory keeps interactive performance high, a critical factor for such applications as visualization and as a server for workstations. Unfortunately, I ran out of G's long before the C3800 ran out of features. For the 3 G's, I'll add a few more letters. O is for open supercomputing, a high-performance system that everyone in the organization can access and use. Unlike traditional mainframes and proprietary supercomputers, the C3800 family continues Convex's technology leadership role with industry-standard interfaces, environments, and software development tools. For example, Convex has always supported Unix and standard I/O buses like VME, HIPPY, and has performed arithmetic processing using IEEE standards. With the C3800, supercomputing is transparent to the user, except, of course, for that boost in performance. C is for compatibility. The C3800 is software compatible, both upward and downward, with all members of the C3 family. The broadest range of industry software, more than 1,100 third-party Unix-based applications, make the supercomputer features of the C3800 available to users on day one. M is for modularity. In the C3800, you can add CPUs and IOs to the system. Initially, you can start with 1 CPU and 1 IO. Since CPU and IO can be incrementally added, you can grow the system to a maximum configuration of 9 CPU IO subsystems, and the expansion can be accomplished on-site. D is for advanced diagnostics systems that features an artificial system called Catalyst. This system is workstation controlled. Unix is used as a diagnostic operating environment. This means that the operator uses one environment, Unix, to both control the system and to perform the diagnostics. Each 3800 has hardware-implemented scan rings surrounding logic circuits. These scan rings are used to apply diagnostic stimuli and to obtain the results. Through the Catalyst AI environment, the results of these tests are used to locate failed subsystems. And finally, A is for anything, because now with the C3800 family, anything is possible. Thank you very much.
Hi, Jim Balthazar here again. As you know, Convex computers are installed throughout the world. Up next is a video segment that illustrates how a Convex supercomputer is being used for weather forecasting in Scandinavia.
The Danish Meteorological Institute in Copenhagen is responsible for weather forecasting in a geographical area which extends from Denmark north to Greenland. To provide fast, accurate weather models, DMI employs a Convex 220 supercomputer. Lars Pram is director of the institute and was instrumental in the decision to acquire a Convex.
We looked at all available supercomputers at the market. We needed a very fast computer, we needed a large memory, and we needed a Unix operating system, and at last we also needed a machine which has high reliability on the software and the hardware.
Preparing hourly forecasts is a time-consuming and complex job, but one that is made more efficient by the Convex.
To produce a weather forecast, you have to go through a long number of different activities. First, you have to do measurements to find out how is the weather now when you start your computation. And when the computation is finished, we had to start up our oceanographic models and other applied models, air pollution models and so on. And all the data are synthesized by the graphic software and presented on workstations.
Because the work at DMI is so time critical, it was important that no time be lost in the conversion to Convex.
The most important question was whether we could install our existing software at the Convex computer within a reasonable time and then develop it further. And it showed up that by use of the support from Convex, the software people from Convex, we were able to install the software very fast and get the operational system running very fast.
Looking to the future, DMI has made the decision to acquire a Convex C3 series supercomputer to further increase their work capacity and efficiency.
We need to have a forecasting model with even higher resolution. Therefore, we have been looking for even faster machine. And we are happy that Convex is able to offer a C3 machine which has the required speed. Our users and customers has been used to high quality, detailed products. It's only with a supercomputer a meteorological institute can stay at the top of the productivity and quality.
With the 3800 now giving true supercomputer users another choice, let's set our sights on the mainstream of our current business. While the 3400 family represents a logical move from the C2 series, it's really much more than that. It's more than just the next generation. This member of the C3 series combines the architectural features of the 3800 with an innovative RISC implementation that provides for more expandability and potential for future growth more than any other supercomputer in our Convex C series. Here's the supercomputer that features the most highly integrated processor ever designed, using both BiCMOS and gallium arsenide technologies. Here's the biggest surprise in the C3 series. Here's the 3400.
Introducing the C3400, now the most expandable mid-range convex supercomputer. With the power of the C3400, users can now run visualizations in less time and see results right on the desktop. The C3400, the solid solution for the departmental user. Ladies and gentlemen, please welcome the Senior Vice President of Engineering, Frank Marshall.
Good morning. As both Bob and Jim have said, the C3400 has got to be the big surprise of this announcement. Here is a new mid-range supercomputer family that quadruples the peak performance and doubles the expandability of its previous generation of supercomputers. Expandable from 1 to 8 processors, the C3400 is a C-series compatible processor that was implemented using RISC techniques. For the first time, BiCMOS and gallium arsenide have been used together. With this choice, the C3400 design is scalable to even higher performance levels in the future. While the C3400 shares some features and benefits with the C3800, it stands alone as a great example of convex innovation. Probably its most dramatic feature is its high level of integration. The highest level of integration, in fact, than any other supercomputer. The sophistication and density is so great that the CPU is contained on a single board. This improves system speed, reliability, and mean time to repair, while reducing system size and cost. The streamlined CPU architecture uses BiCMOS semiconductor technology. The 150,000 gate BiCMOS gate arrays with high-speed internal static RAM provide the performance advantages of high-speed bipolar and high-density CMOS semiconductors. This offers ECL speed at a fraction of the power requirements. And in addition to the BiCMOS gate arrays, the C3400 employs full custom gallium arsenide floating point units to further increase performance and reduce power requirements. This innovative blend of technologies, BiCMOS for logic and gallium arsenide for floating point arithmetic, produces one of the best price performance factors available anywhere. It allows the C3400 to be an incredibly compact machine. Compared to the C2, it has twice the number of processors in half the footprint with half the power consumption per CPU. In the C3400 family, like the C3800, each of up to 8 64-bit CPUs is a supercomputer that integrates high-performance scalar, vector, and parallel processing. So whether you've got 10 users or 100, the processing power is dynamic. And as I mentioned earlier, the high-speed scalar architecture increases performance. All instructions with high frequency of use have been implemented in one CPU cycle. The instruction stream is highly pipelined. In the area of memory, the C3400 offers memory capacity to match peak vector performance. This is the feature of a true supercomputer and provides sustainable peak bandwidth of 800 megabytes per second. Main physical memory of up to 2 gigabytes is complemented by a virtual memory system of 4 gigabytes. With all these technological advantages, there's one last feature of the C3400 that may be the most important of all: compatibility. The C3400 fits in the mainstream of our business and has a much broader range of uses than any other family member in the C3 series. Let's examine some of these features that the C3400 has in common with the C3800. First, they both operate in the same open supercomputing environment. This is a high-performance system that everyone in the department can use, with interfaces, environments, and software development tools that make supercomputing nearly transparent. Unix and POSIX compliance are part of the Convex operating system, a true supercomputer operating system tuned for large multi-user workloads. Both the C3400 and C3800 families have familiar user interfaces and environments. These eliminate learning curves and associated costs so that users are immediately productive. And open supercomputing offers access to a variety of connectivity standards. Both product families are symmetrical, multi-processing parallel supercomputers. They both share dynamic CPU scheduling with Convex's unique ASAP technology. This reduces time to solution on a single job and maximizes job throughput for many users. They both share the same integrated intelligent I/O subsystem that balances raw processor performance with peripheral and network data transfer performance. Based on industry standard bus interfaces, the I/O system supports the most widely used tape and disk storage devices, terminals, printers, and plotters. Plus, Convex provides interfaces to large arrays of disk and robotic tape systems to satisfy enormous data storage requirements. While each I/O port of the C3800 supplies up to 500 megabytes per second of bandwidth, the C3400 supplies up to 200. Finally, both the C3800 and the C3400 share the same distributed visualization tools, technically advanced development tools, and the broadest range of Unix-based software in the industry. More than 1,100 third-party applications and growing by the day. A mere 3 years ago, the C2 series established Convex as the undisputed leader in departmental supercomputing. I think it's fair to say that everyone has been expecting the 3800. After all, what grabs the headlines is the highly anticipated Convex versus Cray showdown. But in the next few weeks, people are going to be writing and talking about the C3400. A lot can happen in 3 years. The C3400 quadruples the peak performance and doubles the expandability of the highly innovative C2 series at about the same price point. Once again, Convex surprises the industry and sets sights on a bigger share of the mid-range market. There's no doubt in my mind that the 3400 will improve our existing leadership position. Thank you very much.
Designing automobiles is a complex job, but in our next video segment, you'll see how Ford Motor is using a Convex supercomputer to help make their design process more efficient.
Every year, automakers spend thousands of hours and dollars in an attempt to design the safest and most efficient automobiles. In Dearborn, Michigan, Ford Motor Company is using a Convex supercomputer to decrease the time from engineering design to assembly line. Howard Crabb heads up Ford Motor's Alpha Research Center.
At Ford, we're developing a new strategy that will allow us to perform computer-aided engineering early in the design cycle before prototypes are built. This will enable us to design a top-quality product in a reduced time frame, as well as reducing the cost of the product to our customers.
At the center of Ford's new strategy is a Convex 240 supercomputer. With the ability to provide visualization of large amounts of data, Convex is providing solutions that translate into cost savings.
One of the benefits of owning our own Convex is that it allows our engineers to do many analysis early before hardcore decisions are made. Another benefit is that we really don't know the Convex is there. It's transparent to our end users and is very easy to use. A third is the mean time to failure. The machine is always available, and it is very, very infrequent that any problems are encountered with the hardware.
For the engineers at the Alpha Research Center, the performance of their new Convex was a pleasant surprise.
After the Convex was installed, it was interesting to observe our engineering community. It's the first time where I've actually seen analysts get a surprised look on their face. The response time to get an answer was dramatically changed, and their whole environment became a much improved environment because they were able to begin to do analysis quickly and easily.
A key ingredient in any customer relationship is product performance and the service and support that the customer receives after the sale has been made.
Our current relationship with Convex is outstanding. It's a rather unique situation insofar as that we really don't see Convex that often because their hardware runs, it doesn't break, and we just use it 24 hours a day. The software runs as specified.
As in any industry, the importance of planning ahead is vital. And at Ford Motor, that future is linked with Convex.
Our immediate plans over the next 3 to 6 months are to acquire a new Convex C3 machine. In looking into the future 2 to 5 years, I think we're living in extremely exciting times. I foresee dramatic changes in the engineering workstations as well as the communication, networking, and supercomputers. And I feel that Convex is moving in the right direction by introducing a multi-parallel machine.
Please welcome once again, Jim Balthazar.
What do you get when you cross a C2 architecture with a 34 and 3800 technologies? The answer, the C3200 family, at a price half of what the previous C2 series was. In spite of its low entry price, however, benchmark studies do show that a 4-processor 3200 offers 90% of the throughput of a single processor YMP, which, by the way, can cost up to 10 times as much. Here's the supercomputer that opens up even more market opportunities for us. Here's the most cost-effective system in the C3 series. Here's the 3200.
Introducing the C3200. Combining leading-edge engineering with cost-reduced manufacturing, Convex now provides low-cost supercomputer performance in a server environment. With over 1,000 Unix-based third-party applications, the largest library in the industry. With double the price performance of previous Convex supercomputers, the C3200 is the supercomputer for those who thought they couldn't afford one.
Well, so far today, we've given you an awful lot to think about. We're announcing one new series, the C3, 3 new families, the 38, the 34, and the 3200, with 20 new systems within these families. I think it's important to have a clear understanding of each family's reason for being. The 3800 is the world's first gallium arsenide supercomputer, our high-end product designed to open up a new market for us at the high end of the supercomputer price performance spectrum. The C3400 is a RISC implementation of the 3800 architecture designed to offer lower cost, easy expandability, and the advantage of future scalability to the middle of the spectrum. The C3400 has double the performance and expandability of the C2 series. The C3200 is based on proven C2 series technology with cost-reduced and enhanced reliability features derived from the C34 and 3800s. The 3200 is about half the price of a C2 system and is designed to reinforce our price point at the low end of the supercomputer market. I think the reaction to the C3800 is going to be, wow, true supercomputer performance at an affordable price. I also think that the reaction to the 3400 is going to be incredible innovative RISC technology and a great upgrade path with future scalability potential. And I'll bet that the reaction to the C3200 is going to be, I can finally afford a supercomputer. As I said earlier, the C3200 is based on proven C2 technology at half the price. While engineering the higher-end C3 products, we were able to implement cost-reduced technology, enabling us to pass these savings along to our customers. This low-cost implementation of the 3200 includes a restructured memory crossbar using new low-cost technology, high-density, cost-saving CMOS gate arrays, and a new subsystem that features 4 megabit DRAMs that provide users a more cost-effective upgrade path to the maximum of 2 gigabytes of physical memory. Memory costs have also been reduced by over half. Enhanced reliability features include a redesigned thin film backplane that increases pin connectivity and more reliable power distribution, designed to maximize the system's uptime. The 3200 offers many of the same qualities that many of the C3 series have: more efficient and effective open standards, proven design, ASAP parallel technology, high performance memory, and intelligent I/O. And of course, the C3200 offers the same powerful visualization tools, advanced compiler technology, optimized application, and support services that are Convex's hallmark. When you add up all the features of the 3200, you've got, very simply, the best value in supercomputing. As you've seen, Convex supercomputers are used in a wide range of tasks. Our next video segment profiles Delft University in Holland, one of our very first European customers, who is using the Convex for scientific and educational research.
Delft Technical University in Holland is one of the oldest and largest universities in Europe. At their sprawling campus, some 14,000 students and faculty are engaged in high-level scientific research and education. In 1986, Delft discovered they had outgrown their existing computer systems and turned to Convex. J.C. Zwijdervaart is director of the Delft Computing Center.
Convex could provide us a solution for our problem. Convex had a new supercomputer, a mini supercomputer it was called at that time, with a high performance, 10 times more performance than our mainframe, but with much lower costs connected to it.
The departments of aerospace and civil and electrical engineering are among the most frequent users of the computer center. To access the Convex, they use a high-speed network.
The installation of our Convex was done in April '87. It went along with the installation of our university network, and that was a big advantage because in one, at the same time, the Convex became available for 600 working places of users within the faculties. So networking was a big advantage of the Convex. The Unix operating system was a big advantage, but the major point why we choose Convex was the availability of a large class of application software.
As head of the computer center, it is the job of Herr Schweiderwart to keep his customers happy. For the computer center, that means anticipating user needs and planning for the future.
The people in the computer room were accustomed to our mainframe, to IBM computers and what's connected with that. But with the increase of the Convex computer within the computer room and the reaction from customers to that systems, they changed their attitude 180 degrees. They are now considering it as their pride, and they are very enthusiastic about having the new C3. The main reason why people like the Convex is because it is a very usable machine. It has a high performance. It has a large library of application software. And in that respect, the Convex performs very well, and I don't know any other computer in this range of supercomputers that performs even or better than Convex.
As Bob stated at the beginning of our meeting today, isn't just an introduction of a product. It's a continuation of a report on the business strategy that Convex originated in 1982. The C1 kick-started our growth, and the C2 accelerated it. And there's no question that the C3 will take it into turbo drive. I guess the next question is, so where do we go from here? To look into the crystal ball of supercomputing, here's our technological leader, Steve Wallach.
To tell the truth, I don't think I'm giving away any wizardry secrets here. If you look at the past, you can pretty much predict the future. Our business strategy has already been discussed by Bob and Jim. You know it's working because of our fantastic growth. With 2 points, you have a straight line. With 3 points, you have a straighter line. Our 3 points are the C1, C2, and C3. What they point to is a continuation of this successful business strategy. Let's begin our look at the future by looking at software. Our goal is to continue to develop user environments that make our products easier to use. Let's first look at compiler trends. When I went to school, with wisdom, people said use Fortran. Then eventually, Fortran's going to go away. Let's look at PL1 and Algol. Went to industry, and what did they say? Forget that. Always use Fortran and Fortran. When we get into the supercomputer realm, what happened? The first vectorizing compilers were pattern matched. They were very inefficient. Why were they inefficient? Infinite number of patterns can't do that. When with the announcement of the C1, Convex introduced the world's first automatic dependency-based compiler. Very rapidly, there was automatically parallelizing of vectorizing C, parallelizing of vectorizing Ada, and last September we introduced the world's first interprocedural analysis compiler. Where are we going in the future? Eventually, we have to integrate all the tools, all the development tools, including CXPA, CXDB, into one user environment. Again, it's ease of use, highly optimized code. User cycles are becoming more important than CPU cycles. We next go from the compilers, we have to look at the base, the operating system base. What's the environment that we're going to work in? Well, it's really interesting. This is a new chart, and I sat down to develop it, and I said, gee, we're as innovative in operating systems as we are in compilers. We just never viewed it. In fact, we have our 3 and 4 points. First, we chose Unix. People ask, why did we choose Unix? Because it cost $44,000. But you get what you pay for. So we substantially enhanced it over time. Unix was initially developed for the research community, a small number of users. While it works well in that community, it doesn't work well in the supercomputer environment. So over time, we've added disk striping, the first Unix to have disk striping. From the disk striping, we've added checkpoint restart, fast share scheduling. With the release of the C3 family, we also eliminate the bottleneck of individual files being smaller than 2 gigabytes. Now we can go up to 1 terabyte for an individual file. Eventually, we will enhance our operating systems to work in heterogeneous environments. That is, what does it all mean to have computers of different instruction sets working together? So again, we'll continue this evolution. Now again, it's to have computers work together. So let's see what some of these configurations will look like. When the company started, and to a very large extent exists today, it was workstation server model. But we weren't necessarily as clever then, or didn't anticipate it, that today the standard model is workstation server. When we started, people had workstations on their desk. Convex was a technical compute server. We, in a sense, weren't just doing supercomputing, we were in a technical compute market. What made this all feasible, of course, was standards. Unix, IEEE, Ethernet, TCP/IP. And we were one of the originators of this particular concept. Now, as we grew into bigger and bigger hierarchies of computers, we expanded from the workstation server level at the department level to the whole hierarchy. We heard how Howard Crabb and Mobile talked about hierarchy of storage and hierarchy of computing. Well, what we have here is, here we go. What we have here is the notions of central site, departmental, and workstation. And the reason this is a very powerful concept because most companies and research organizations have this particular organizational structure. People are working at their desk with a workstation, they work in departments, and departments work in larger organizations. So consequently, the networking structure as well as the operating system should reflect this particular organization. So we've seen the past, the present, now where are we going in the future? What will computing look like in the 90s? Well, something that we've come to know as Frank Marshall's cloud. And let me explain that. When we started out, we had this notions of, again, we were in a technical computing market. But what we found over the last several years is that's not really what we're in. What we're really in is the shared resource or server marketplace. We're a utility to workstations. The workstations are our customers, they're the clients, and we're the servers. And we serve them by providing compute cycles, file access cycles, database cycles, etc. And we'll discuss this a little bit further. But the key is to be for this computing model in the 90s, you have to not be as myopic as a lot of other companies. You have to take a broader view of the world. And in fact, that is the view that Convex is taking. This is the model of the 90s. But creating leading-edge supercomputer software and open supercomputing is only part of the story. Let's look now at the hardware of the future. Well, going back to the chart, first of all, we're going to have more processors. Now, again, let's see what happened. The C1 had one processor with 128 megabytes of physical memory. C2 had 4 processors initially with 1 gigabyte of memory. C3 family goes up to 8 processors with 4 gigabytes of memory. So the obvious question is where we're going in the future. What's the C4, C5, C6 going to look like? Well, it's going to have more processors and more physical memory. We will continue this process of every generation coming out with more and more processors, each processor being faster than the previous generation, and more physical memory. We've done this 3 times and we'll continue to do it. Now, what's going to be the baseline technology? How are we actually going to implement that? Well, it clearly has to do with semiconductor technology. There are 2 ways of looking at semiconductor technology. In the upper left-hand corner, you see with DRAMs. Quite coincidentally, we've been shipping machines every 3 years, and guess what? There's been new generations of DRAMs also 3 years. I don't think that's necessarily a coincidence. Now we're going to 4 megabit DRAMs. Over the next 3 years, we'll be moving to 16 megabit DRAMs, and then to 64 megabit DRAMs. The consequence of that will mean in 3 or 4 years, we'll begin having 16 to 32 gigabytes of DRAM in a small air-cooled environment. The other charts show the trends in baseline technology, in this case ECL and CMOS, in terms of number of gates. Well, if you extrapolate that out, a C3800 CPU nominally has 1 million gates. If in 4 or 5 years I can get 1 million gates on a chip, which I will, you can have now the power of a 3800 CPU in one single gate array, which means I can have more processors, cheap, air-cooled, because they'll be in one package. Now, this obviously brings us to the point, where's this going? What are we trying to solve? What are some of the grand challenges? We keep making computers faster and faster, and some people say, what is left to be solved? Well, this was produced by, it was called the Bromley Report for something called High Performance Computer Initiative. And what they show is the type of challenges called grand challenges that we're trying to solve by the year 2000. Things like vision, turbulence modeling, human genome. And to do this, you have to get into the teraflop of performance and have hundreds of gigabytes of memory. And Convex is moving in that direction. So to see what kind of products we will be offering in the year 2000, let's take a final view. Well, first of all, going back to the semiconductor slide, we'll probably have close to 1 terabyte of physical memory, all directly referenceable. That's kind of awesome when you think that it's more physical memory than most people have disk storage today. We'll clearly be in the teraflop range, and for those who don't know, after tera comes peta, P-E-T-A. So just like we had to learn giga over mega, and we'll learn tera over giga, probably in 10 years we'll be learning peta over tera. However, the machine will still be easily programmed. In fact, and this may sound like a contradiction in terms, the machine will be a general purpose massive parallel machine. By my definition, general purpose means I sit down, I program in Fortran or C and its derivatives in the year 2000, and the compilers in the operating system transparently make your programs work over hundreds, if not thousands, of processors. So this leaves us then, if that's what the computer is going to look like, let's see what the final configuration will look like. The notions of shared resources, again, going back to the cloud. As we evolve from the original slide of workstation server, we're now evolving to the shared resource model. And what are we sharing? We're sharing not just a computer, but we're sharing scalar processing, vector processing, massive parallel processing, data service, file service. We have departmental servers, and these are all connected together in either a high-speed network or via a high-speed back panel interconnect. And as we evolve towards this structure, it would only make sense for us to ship this and support it when the software is available. And in fact, we're doing both. This way we can incrementally provide our customers more compute power and more services. So concluding, we have all these exciting projects, we have this vision. So my vision of supercomputing in the year 2000, it's my vision and I hope it's yours. Now right now we'd like to show you how another customer is using the power of Convex. Thank you.
The
The face of American universities is changing. As the world shrinks, students are called upon to learn more than just the basics. On the campus of the University of Illinois, students are exploring the origins of the universe, using the capabilities of the Convex 240 supercomputer. At the National Center for Supercomputing Applications, Director Larry Smarr is leading students on journeys never before possible.
At NCSA, we are developing a garden of computer architectures all hooked together by high-speed networking. But what we were looking for is a supercomputer that could serve as sort of the smart bit bucket in the middle of our numerical lab, the thing that after you've made your run on another computer, you bring your solution, put it into this machine, and then tie all kinds of future-looking graphics devices into it, and actually sit down and fly through your space-time in real time. Get that solution into your skin. I mean, get that intuitive sense of what has been computed here in this artificial reality. And the Convex seemed perfect for that.
Investigations into cosmology is one of the research projects at NCSA. Researcher Mike Norman is using the Convex to explore the dimensions of the universe.
Cosmology is a long and fairly deep scientific discipline that has been mostly observational up until the recent decade. With the advances in supercomputer technology, we can now make model universes. So with powerful application software, with Convex and a powerful visualization workstation as tools, we can explore our universe in space and time and understand how we came to be.
For Larry Smarr and his researchers, the introduction of the Convex provided a platform for work that was not possible before.
Within the first month of the Convex coming here, the most unexpected thing to me was to see how it just dovetailed perfectly with the connection machine, with the Silicon Graphics Iris, with our whole network environment here. What that meant was that we could tackle grand challenge problems like 500-hour astrophysics runs in 3D. I mean, it was just amazing. I mean, it's the way it's going to be in the future, and the ability of it just to sort of slip in there and to be just literally doing this within a few weeks of its arrival just blew me away.
As with all Convex users, the support that's received after sale and installation is one of the main reasons why customers continue to look to Convex for their supercomputing solutions.
One of the things that I have been most pleasantly surprised about in working with Convex is the personal relationship that Steve Wallach and I have developed. That is very important to me because it's hard, without being able to get to the soul of the computer company, it's very difficult for me to do our magic. The next 5 years are going to be one of the most competitive periods in the entire history of supercomputing. I think Convex is well positioned. It's got a very clean company. It knows how to compete. It has a very wide product line. It has a scalable product line, which is what's absolutely necessary these days. So for all those reasons, I think that the introduction of the Convex C3 is going to be a rather historic moment in the supercomputing industry.
This is a historic moment, isn't it? We've just put you through about an hour of facts and figures, systems and strategies, markets and messages, not to mention megas and gigas and teras. That's a lot of output for us to give to you and an awful lot of input for you to comprehend. But I want to tell you right now, don't worry about missing any of the details, because certainly between what you're going to go through today and tomorrow and the packets that you've got on the desk, as well as additional ones, you're going to be able to take home with you all the details that you need. What I want you to remember, though, from the events that you saw here today was really three simple things. I want you to remember that Convex is not just announcing a new high-end product line. Rather, we're bringing to both existing as well as new customers 3 new supercomputer families, one that addresses each segment of the supercomputer market, the high-end, the mid-range, as well as the low-end. Now we have a product for every customer's need. I want you to remember that with the C3 series, Convex now has the broadest series of compatible supercomputers in the industry. We have the richest supercomputer system software environment, and we have the most third-party application software, over 1,100 applications, and I'm sure the C3 is going to inspire many, many more. And more than anything else, I want you to remember that our business strategy, our strategy for growth, is working. We continue to spread supercomputing to a wide range of users all over the world. We now have more customers, more installations, in more countries, with more software than any other supercomputer manufacturer. And with the 3 families of the C3 series we've introduced today, our strategy continues to evolve. Steve said that if you look at the past, you can pretty much predict the future. That's never been truer than today with Convex. We'll continue to add new markets, new uses, and new opportunities for growth. And most important, we'll continue to bring value and supercomputing leadership to our customers.